Hey students, lesson 6.4 here. In this lesson, we're going to learn how to choose the best method for solving a system of linear equations. Go ahead and do the review. I'll check back with you. All right, so we're trying to learn how to use the best method to solve a problem. And here's just a concept summary. If you just need an estimate of the solution, or you want to see something visually, then use a graph. When one of the equations is already solved for one of the variables, or when it's easy to solve for one of the variables, then go ahead and use substitution. And use elimination when the coefficients of one variable are the same or opposites, or when it's not convenient to use graphing or substitution. So here we have a problem, finding a break-even point. And so the carpenter makes and sells rocking chairs. The material for each chair costs $22.50. The chairs sell for $75 each. If the carpenter spends $420 on advertising, how many chairs must she sell to break even? And I would suggest on this one that you could just graph it, and but either way, we're going to need some equations to solve this. So let's let n equal the number of chairs that are sold. And we'll let c equal the cost to produce them. And then we're going to let I equal the income from selling them. Now, using those variables, we get the cost to produce chairs is equal to $22.50 per chair. That's just the materials. So we're going to multiply $22.50 times the number of chairs we sell. And there's also some advertising costs that are added to that. And then the income from sales is they get $75 per chair, so it's just 75 times the number of chairs. Now, to break even, that means that the cost is equal to the income. So C is equal to I, and we can just substitute for C, $22.50 n plus $4.20. And for I, we can substitute 75n, and then we can just solve that equation. So you might subtract $22.50 n from both sides. And then you get 420 equals 52.50 n. Divide both sides by 52.50. And you get n is 8. So if you sell 8 chairs, the cost to produce the chairs and the income from selling the chairs is the same. So you'll break even on those. Go ahead and try problem 1 here. All right, the next problem we're going to try and solve and pick a method to do that is a problem involving mixing solutions so that we get the correct number of ounces and the correct percent of whatever it is we want. In this case, it's acid. So we want to know how many fluid ounces of each of these concentrates, some at 2% and some at 5%, should be combined to make 25 fluid ounces. To do that, we're going to let X equal the number of ounces of 2% acid that we use, and let Y equal the number of ounces of 5% acid we use. And if we do that, then we know we want to make 25 fluid ounces of solution. So one equation we can use is just say that our 2% acid solution plus our 5% acid solution should add up to 25 ounces. And then our other equation is going to come from the amount of acid in the solution. And so if we take 2% of our solution, that is 2% solution, plus 5% of our 5% solution, and we add those together, we should get the amount of acid in the whole mixture, which we want to be 3.2%, and 3.2% as a decimal looks like that, but that's 3.2% of the total 25 ounces. So, and then that can just be simplified to 0.02x plus 0.05y equals 0.8. All right, now we have a system of equations. So here's one equation here. Here's another equation here. We could use substitution here, but I think I like using elimination here. What I'm going to do is multiply this equation here by 100, and that'll get rid of my decimals. So I get 2x plus 5y is equal to 80. And then I'm going to multiply this top equation here by -2. And that will give me -2x plus -2y equals -50. Now I have two equations with opposite coefficients, so I can just add these together and I get 3y equals 30. Divide both sides by 10 and I get by 3 and I get y equals 10. Well, I know my total solution is 25, so if y is 10, then that means that x is 15. So I'm going to use 10 ounces of the 2% solution and 15 ounces of the 5% solution. I'm just going to check that to make sure that that ends up being what I want here at the 0.8. I'll show you the work there. And so you can see how I check my work here using the 2% and the 5%. All right, go ahead, you try one of those. All right, here's another problem that we can use a system of equations to help us solve. So it deals with trying to figure out what the current speed is and what the actual speed is of a kayaker. So if you check the speed of a kayaker and notice that they're going 5.75 miles per hour paddling with the river current and 3.25 paddling against it, what would be the speed of the river current? Okay, so let's let x equal our speed without the current, so just if there was no current at all, what our speed would be, and let y equal the speed of the current. If we do that, then if I add x plus y, so I'm adding my speed without the current plus the speed of the current, that should give me my paddling with the current speed, which is 5.75. And if I take my speed without the current and subtract the current speed, then I should get my speed when I'm paddling against it, which is 3.25. Well, now you'll notice here that both y's, they have opposite coefficients, so we can just add these two equations together and use elimination here. And we get 2x equals 9, divide both sides by 2, and we get x equals 4.5. That is the speed of the kayak without current. So if we take that and add our speed of our current, we should get the speed with the current, which is 5.75. Subtracting 4.5 from both sides, we get y equals 1.25. And that is the speed of the river current. You try that. All right, that's the end of the lesson today. Go ahead and do the lesson check, and we'll talk about this next time we meet in class.